In the last video, we started talking about naming binary ionic compounds. We saw that we actually have to look at the periodic table to determine the charge of each ion to come up with the formula. Now we're going to still be looking at binary ionic compounds, but these ones are a little bit trickier. These are considered type 2 binary ionic compounds, and what's special about them is the metal can form more than one charge. So when we were looking at the periodic table, we said our alkaline metals are always a +1. We said our alkaline earth metals are always a +2. We said over here underneath boron, all of these metals here are a +3. But here's the problem. All of these metals in the middle, all of these metals down at the bottom, and then my metals underneath the row I skipped, so tin and lead, these metals can form more than one charge. Sometimes they're a +1, sometimes they're a +2, sometimes they're a +3, they can even be a +4. It depends on the metal. There's no set charge for them, and so I have to determine the charge either from the name, or if I'm giving the formula, I can determine it that way. But it makes life a little bit trickier, okay? So the way it works is because there's more than one charge, I need to specify the charge. So I need to tell people which ion I'm working for. Is it iron 2? Is it iron 3? Is it copper 1? Is it copper 2? Is it cobalt 2? Is it cobalt 3? I need to be specific, okay? The way I'm going to do that is I'm going to use a Roman numeral. Now, in case we've forgotten Roman numerals, because they're not used a lot, 1, the Roman numeral, is a capital I. 2 is 2 capital I's. Easy enough. 3, oops, 2, 3 is 3 capital I's. 4 is where it gets a little trickier. 4 is an IV. 5 is just a V. Now, normally you won't have 6s. We might have a 6 occasionally. 6 would be a VI. Okay? So we need to know these Roman numerals. Now, the way we determine the charge on our metal is by looking at the charge on who it's partnered up with. So for example, here I've got my compound. I know Cu is copper, so I'm going to name that. I'm going to leave a space for my Roman numeral. I know Cl is chlorine. I also know that because it's my second ion, I change the ending to IDE. Now, to determine my Roman numeral, I need to look at not copper, because I don't know the charge of copper, but I need to look at the charge on chlorine. If I look at chlorine, chlorine's always a -1. Now, because there are no subscripts, I know that the charges have to be the same, so because chlorine's a -1, copper also has to be a 1, but this time it'll be positive. So when I name this, I'm going to call it copper 1 because that's the charge on my copper. So copper 1 chloride. Same thing on this next one. Hg is mercury. Mercury can form more than one charge, so I'm going to leave a space for the Roman numeral. O is oxygen. I know that because it's my anion, I need to change the ending to IDE. Now again, I don't know the charge on mercury, but I always know the charge on oxygen. Oxygen is always a -2. So I'm going to put that here. Again, because there's no subscript, no little number by mercury, no little number by oxygen, I know that the charges are the same, so this 2 needs to go by mercury. Instead of a -2, it's going to be a +2. So when I name it, I would call it mercury 2 oxide. Okay? The last one is going to be a little bit trickier because this time I do have subscripts. So when I name it, Fe is iron. I'm going to leave a space for the Roman numeral. O is still oxygen. I change the ending to IDE. This time I have to figure out the charge. Well, oxygen is still a -2, but this time I have subscripts. Remember, when the charges weren't the same, we switched them. So because oxygen was a -2, I needed 2 irons. I have 3 oxygens. Where that came from is the charge on Fe. I switched them. So Fe was a 3. Because it's a metal, it's a plus. So I would call it iron 3 oxide. Okay? Remember, this 2 on my charge went to the subscript there. This 3 came from the charge because they go across. Okay? When I'm writing the formula, it's a little bit easier because they actually tell me the name or the charge in the name. So I've got manganese. Manganese is Mn. They tell me it's manganese 4, so it's a +4 charge. It's partnering up with oxygen. Oxygen is still a -2 charge. Now, because the charges don't match, I switch them. So this 2 comes over by manganese. This 4 comes over by oxygen. And when I write the formula, it's Mn2O4. Now I could leave the formula like this. However, formulas are usually written in the simplest form. So 2 and 4 can be simplified. 2 goes into 2 once, so I would write it as Mn1, or just leave that subscript off. 2 goes into 4 twice, so O2. Okay? These are both equivalent. This is just the simplified version. And when we're doing ionic compounds, we write the formula in the simplest whole number version. Okay? Same thing with lead 2 chloride. Again, they tell me that I've got lead with a +2 charge. I've got chloride, which is chlorine. If I look on my periodic table, chlorine is always a -1. 2 and 1, because my charges don't match, I switch them. I bring the 1 over by Pb. I bring the 2 over by Cl. So I've got Pb. I only need one of them. I can write the subscript, or I can leave it off. Cl. This time I have 2 of them, so it's PbCl2. Okay. So the difference between the type 1 binary ionic compound and the type 2 is now I don't always know the charge of my metal. Okay? So I still have to look at the periodic table. If I know the charge, it's type 1, and I don't have to worry about it. If I don't know the charge, it's type 2, and I need to tell people that charge with Roman numerals. Okay?